Alright guys, I need to talk about something that is happening in the atmosphere right now that almost nobody in the weather community is giving enough attention to, and when you understand the full picture of what is going on, I think you are going to be genuinely surprised. Because what the atmosphere is doing in June of 2026 is something that does not happen very often. And what it is setting up for the rest of the year is something that could rival some of the most significant weather pattern shifts in recent decades. So let us get into this, because there's a lot to cover, and every piece of it connects to the others in ways that tell a really important story about where the weather is heading. Let us start with what is happening right now that is already unusual. If you follow severe weather at all, you know that May and June are historically the peak months for tornado activity across the United States. Based on data from 1991 through 2020, the United States averages about 265 confirmed tornadoes in May and around 212 in June. Tornado Alley in Oklahoma, Kansas, and Texas is typically roaring by this point in the season. The Midwest is seeing regular severe weather outbreaks. The Storm Prediction Center is issuing enhanced and moderate risk outlooks multiple times a week. That is what a normal May and June look like. That is not what 2026 looks like. And the reason why is one of the most significant atmospheric stories of the year so far. The ongoing transition from La Niña to El Niño has produced a weather pattern in May and June of 2026 that has dramatically suppressed severe weather activity across exactly the regions that would normally be most active right now. The National Weather Service data documenting the 2026 tornado season tells the story clearly. A weaker subtropical jet stream and very little wind energy in the upper atmosphere has left thunderstorms without the rotational energy they need to produce significant tornadoes. The northern branch of the jet stream has been sitting well up into Canada, rather than diving down into the central United States, where it would normally be providing the wind shear that severe weather depends on. Persistent troughing in the eastern United States has been spreading cool, dry air across the central plains, limiting the instability and moisture that large tornado outbreaks require. The result has been a May and June tornado season that is running dramatically below the historical average in exactly the places that normally drive the seasonal numbers. Now here is where this story gets really interesting, because the suppression of severe weather activity in the central United States is not the end of the story. It is the beginning of a much larger atmospheric shift that is just now starting to show its fingerprints in the pattern. That shift is El Niño, and what is developing in the Pacific right now is not a typical or moderate El Niño event. The latest data from the Center for Climate Systems Research and the International Research Institute for Climate and Society is showing something genuinely remarkable. The probability assessment for El Niño forming and persisting through the end of 2026 is sitting at 97 to 98%. Researchers describe that probability range as remarkably high and narrow. This is not a situation where there is real uncertainty about whether El Niño develops. The atmosphere and the ocean are essentially telling us it is already decided. But the scale of what is developing is what has meteorologists paying especially close attention. The severe weather, Europe analysis of the latest forecast data shows ocean temperature anomalies in the eastern Pacific that are projected to reach +4, 5 degrees or higher by fall. Let me put that in context for you. The strongest El Niño event on record, the 1997 to 1998 event, produced ocean temperature anomalies in that same range at its peak. The 2015 to 2016 event was similarly intense. These are called super El Niño events, and they produce global weather pattern disruptions that are felt on every continent. The latest forecasts suggest that what is developing right now could potentially reach that category of intensity. And the atmospheric fingerprint of what is coming is already showing up in the current pattern in ways that you can see if you know where to look. The velocity potential analysis, which is the tool meteorologists use to map areas of rising and sinking air across the global atmosphere, is already showing the early signature of El Niño's influence on the large-scale circulation. Rising air over the central and eastern Pacific, sinking air over the western Pacific and parts of the maritime continent. A reorganization of the global tropical convective pattern that is the hallmark of El Niño's early establishment. This is not the model forecast. This is the observed current atmospheric state. El Niño is not coming. It is here, and it is already changing the weather. So what does this mean for the weeks and months ahead? Let me break this down region by region, because the El Niño signal plays out very differently in different parts of the country, and I want to make sure everyone knows what is coming for their area. For the central and southern plains, the pattern that has been suppressing severe weather through May and June is not going to last indefinitely. As El Niño establishes itself more firmly, the subtropical jet stream tends to strengthen and shift southward during the late summer and fall. That can actually increase certain types of severe weather potential in the southern tier, even as it suppresses it in the traditional Tornado Alley regions during the transition period. The high plains drought that has been a contributing factor to the quiet, severe weather pattern is worth watching closely over the coming weeks, as the moisture and atmospheric dynamics associated with El Niño begin to reshape the regional precipitation pattern. For the Gulf Coast in the southeast, El Niño is historically one of the most favorable patterns for rainfall during the late summer and fall. The enhanced moisture transport that tends to accompany El Niño events, combined with the stronger subtropical jet stream that channels weather systems more frequently across the southern tier, produces wetter than normal conditions across the Gulf states in the southeast. After a period of suppressed activity, the moisture tap for these regions tends to open back up as El Niño matures. If the event reaches super El Niño intensity, as the current forecasts suggest is possible, the precipitation anomalies across the southern tier could be significant. For the Pacific Northwest and the Northern Rockies, El Niño is historically a warmer and drier pattern. During strong El Niño events, the northern tier of the country sees the jet stream pushed northward into Canada, which reduces the frequency of storm systems tracking through the Pacific Northwest and allows warmer air to dominate. This has significant implications for snowpack in the northern Rockies and Cascades during the upcoming fall and winter, as well as for the wildfire risk in regions that could see drier than normal conditions develop through the warm season. For the Atlantic hurricane season, the El Niño signal is one of the most well-established and most significant influences on tropical activity that exists. Strong El Niño events increase wind shear over the tropical Atlantic, which physically disrupts the development of tropical cyclones and prevents them from organizing into major hurricanes. The NOAA National Weather Service forecast, issued in May of 2026, already called for a below-normal hurricane season with 8 to 14 named storms, specifically citing the expected El Niño development as a primary suppressing factor. If the El Niño reaches super El Niño intensity, as the current Pacific Ocean temperature anomalies suggest is possible, the wind shear across the tropical Atlantic could be even more hostile to tropical development than a moderate event would produce. For Gulf Coast and East Coast communities that spend every summer watching the tropics, a super El Niño would be genuinely good news from a hurricane perspective. Now, let me talk about why the combination of things happening right now is what I would describe as extremely rare, because I want to be precise about what makes this moment unusual, rather than just using dramatic language without substance behind it. The specific combination of a mid-season La Niña to El Niño transition occurring rapidly enough to suppress severe weather during what should be peak season, combined with the potential for a super El Niño event that could rival the strongest events on record, combined with the Atlantic sea surface temperature anomalies that are running significantly above normal at the same time as El Niño is developing in the Pacific, is a set of concurrent conditions that does not have many historical precedents to compare against. The interaction between a warm Atlantic and a strong El Niño is particularly interesting to meteorologists because these two factors do not always move in the same direction. El Niño tends to suppress Atlantic tropical activity through wind shear, but anomalously warm Atlantic sea surface temperatures provide more fuel for any storm that does manage to develop despite that shear. The research community is actively examining how these competing influences interact in the current pattern and what it means for the tail risk of the hurricane season, even if the overall number of storms is below normal. The agricultural and economic implications of what is developing are also worth understanding, because the weather pattern shift we are talking about does not just affect what people see outside their windows. It affects crop yields, water resource management, wildfire risk, energy demand, and a range of other sectors that respond to the large-scale atmospheric pattern. Potentially record-strong El Niño establishing itself in mid-2026 and persisting through the end of the year is an event that commodity markets, insurance companies, water managers, and agricultural planners are all incorporating into their forward planning right now. The bottom line for anyone watching this is that the atmosphere is in the middle of one of its most significant pattern transitions in years. The quiet, severe weather season that has surprised many forecasters is directly connected to the El Niño that is establishing itself right now, and that El Niño has the potential to reach an intensity that would place it among the most impactful events of this type on record. What happens to the weather across the United States and globally over the next 6 to 8 months will be shaped by this transition in ways that will be felt in every region of the country. Stay weather aware, keep watching the pattern, and subscribe to stay updated as this extraordinary atmospheric story continues to develop. There's one more dimension of what is happening right now that I want to make sure gets the attention it deserves, and that is the historical context for what a super El Niño would actually mean in terms of the weather patterns that play out across the country through the fall and winter. Because when you look at what happened during the 1997 to 1998 super El Niño and the 2015 to 2016 super El Niño, you start to understand why the potential for this event to reach that category of intensity is such a significant story. During the 1997 to 1998 super El Niño, The southern tier of the United States experienced one of its wettest winters on record. California, Arizona, and the Gulf states saw repeated rounds of heavy rainfall, flooding, and severe weather that caused billions of dollars in damage. The Pacific storm track was supercharged, with one powerful system after another making landfall along the California coast. At the same time, the Pacific Northwest and Northern Rockies were dramatically warmer and drier than normal, with snowpack running well below average across the mountains that supply water to much of the western United States. The contrast between the wet southern tier and the dry northern tier was one of the most striking regional weather pattern anomalies of the decade. The 2015 to 2016 Super El Nino produced a similar signature with some important differences. California received significant rainfall, but not the extreme totals that some had forecast based on the ocean temperature anomalies. The Southeast saw flooding events. The Gulf Coast had an active severe weather season, and the winter pattern across the northern tier was once again warmer and drier than normal in many areas. Each Super El Nino event has its own specific character, determined by the exact timing, geographic position, and intensity of the Pacific Ocean temperature anomalies. But the broad regional signals are consistent enough across events that seasonal forecasters can communicate meaningful guidance months in advance. What the current forecast suggests for the fall and winter of 2026 and into early 2027, if the El Nino reaches the intensity that current ocean temperature anomaly forecasts suggest is possible, is a pattern with strong historical precedent. A wet southern tier, a drier and warmer northern tier, enhanced storm activity along the Pacific coast, suppressed hurricane activity in the Atlantic. These are the signatures that communities and resource managers from California to Florida to the Great Lakes need to be thinking about right now, because the decisions that are made today about water storage, fire risk management, agricultural planning, and emergency preparedness will be made more wisely with an understanding of what the atmosphere is telling us about where the pattern is going. The fact that this El Nino is establishing itself in mid-June rather than in the fall, which is the more typical timing for El Nino peak establishment, means that its atmospheric fingerprint is already present during what would normally be the peak of severe weather season. That is the specific combination that makes this moment genuinely unusual. The pattern that typically drives the most active severe weather months of the year has been disrupted during those very months by a developing atmospheric shift that will dominate the pattern for the next year. The rare part is not just that El Nino is developing. It is that it is developing fast enough and strongly enough to already be reshaping the pattern during the time of year when its influence is least commonly felt. Watch the Pacific Ocean temperature anomaly data over the coming weeks. Watch the velocity potential maps that show where rising and sinking air is organized across the global tropics. Watch the jet stream position across the continental United States as the summer progresses. All of these data streams will tell you how quickly and how intensely El Nino is establishing itself, and will give you the best available early read on whether the fall and winter pattern shapes up as the current forecasts suggest it will. The atmosphere is doing something extremely rare, right?